So, hi guys, welcome back to our channel. Automation is future. Today we are going to discuss about a new topic called as pneumatics. So, generally we use pneumatic source of energy in industries for making different types of movements. So, we have different sources of energies based on application. We will be going for any type which is suitable for us. So let us discuss in detail what is pneumatics and where it can be used. So, coming to pneumatics, let us go for the definition. Where in common language or in English, pneuma is nothing but air. In pneuma is in Greek language, pneuma is referred as air, and matic is nothing but movement or control. So, if we combine these two, which is nothing but combination of or control of air pressure energy with the help of control movement is called as pneumatics. In generally in industries we refer it as compressed air. So for compression of air, as we know, we will be using generally compressors. There are different types of air compressors available depending upon the amount of air that need to be compressed. So here, if you see in this animation, you can get an idea. So in the animation, we will be having an reciprocating. This is called as reciprocating compressor, where an arm moves up and down, and there is a chamber. Inside the chamber, like when arm is moving to bottom, the chamber gets filled up with air and gets closed up with the air, and whenever it is pushing out or whenever it is going back, it pushes or it makes the air to like get in a confined space, makes the air to get in a confined space. So all these air molecules get tightly packed. So after getting tightly packed, these air molecules have capacity to lift an object. So that way we use this pressurized air. So this pneumatics works on the principle of Boyle's law. Here in animation graphical presentation, you can see whenever the velocity decreases or volume decreases, pressure increases. Pressure decreases, volume increases. So what we will do is we take fixed amount of space. In that, the volume we make it to decrease it at a constant temperature. Okay, at a constant temperature. As a result, the air molecules get tightly packed, and it will make the volume lesser and more pressure. So we have a formula for this. We can take pressure is equals to force by area. So where force is nothing but the amount of mass and amount of movement that that particular product or that particular weight needs to be pushed. So we have like pneumatic air pressure is it is like calculated, we can say, or measured, whatever. So in different types, majorly most commonly used is we call it as PSI, pounds per square inch, and bar, normally used in industries. These two terms are normally used in industries, and we have pascals and newtons per meter square. So the whole relation between the whole like bar, PSI, pascals and newton meter. Here we can see 1 bar is 100 kilopascals, which is equals to 100 kilonewton meters per square, and which is equals to 14.5 psi. Generally, what we see in our petrol bunks and all these is nothing but the psi, pounds per square inch, which we use to inflate our tires. Is we can call it as psi. Okay, in industries we'll use bar. So as we are talking about pressure, so when we go to pressure, they are let us discuss the relation between different types of air pressure. So first one we have is atmospheric pressure, which is nothing but the amount of pressure which is available in the nature or in the surrounding to us. So first let us say atmospheric pressure is nothing but it will be roughly around 0.8 to 1 bar. So whatever the air pressure, and it will be changing to timely, and it will be changing in morning to evening, evening to afternoon. It will be changing differently. And we have like gauge pressure, whatever the pressure that can be recorded on a gauge. Pressure gauge is nothing but gauge pressure. And we have absolute pressure. Absolute pressure is nothing but the change in between atmospheric pressure and gauge pressure is called as absolute pressure. And there is negative pressure also, where we will be using for suction purpose. So as we discussed, atmospheric pressure is nearly up to 1 bar. Gauge pressure, the above the pressure which is above the atmospheric pressure we call as gauge pressure. And generally in industries, the amount of pressure which we use is 5 to 6 bars depending upon type of application we have. And absolute pressure is nothing but the difference between the gauge and the atmospheric pressure. So this is about pressure. And most used sources of energy in industries we have are electricity, pneumatics, and hydraulics. So whereas coming to electricity, most of 90% we will be using electricity in industries, pneumatics and hydraulics depending upon the application. So there are some particular applications and there are some particular these things where we cannot use electricity completely. In those areas or in those applications, in those stations, we will be using pneumatics and hydraulics. Whereas coming to pneumatics and hydraulics, both are kind of same. We will be using fluid power. Whereas coming to fluid power, it is completely a whole different this thing. Uh, in fluid power, all the gases we can say it is pneumatics, and all the liquids we can say it as hydraulics. Whereas coming to gases, we can use atmospheric pressure, which is available in nature, or we will be using different types of particular gas. If you go for like specific applications for pharma, aerospace, we will be using nitrogen. And food industries, carbon dioxide, nitrogen, these ethane, methane, different types of gases. We have specific type of compressors for pulling the air from atmosphere or that particular gas. In hydraulics, we have viscosity of fluids. So depending upon the type of application, we will be going for the grade of viscosity of fluid. So next thing we have is advantages and disadvantages. Whereas coming to advantages, as we know, air is cheap, which is available in unlimited quantity in our atmosphere. The only thing we need to do is place a compressor and we need to pull the air. So and air has basic this thing that it is non-explosive or non-toxic until and unless there is any other fire or something. So it doesn't explode by itself or it doesn't make any particular environment toxic, so that it is very friendly, can be used in food industries, pharma industries, aerospace industries, that way. And it can be transferred for longer distances through pipelines. By making arrangement of pipes, we can make it to transfer for longer distances. And it can be stored, we can store air pressure in tanks. It is fast in operation. As we know, air moves faster, comparatively less speed than electricity, but comparatively to mechanical source of energy and hydraulic source of energy, it is a bit faster. And it is clean to the environment, and the movement and speed can be controlled easily. Uh, Whereas coming to like disadvantages of pneumatics, like it absorbs moisture, and these moisture needs to be removed. And the major challenge that we face in industries is this moisture only. We place at multiple places these filters and drain units, so that we can remove moisture. And whatever the exhaust air, the air passes like as we know, air flows from high pressure area to low pressure area. It creates noise. So to reduce that, in present days we have noise reducers, silencers, all those. But we can say they are doing their job up to 80%. We can say, and pressure is very much limited. High pressure cannot be controlled as we can control in hydraulics. So the major applications that we can see in industries, we are using for storage systems, material handling systems, inspection lines, production lines. They are majorly these are the some of the applications. And here we can see there is a smaller application animation. So here you can see there is a robotic arm which is moving linearly to pick and place an object. We can say that. And here are some other animated videos where we can use pneumatic air pressure for clamping of material, clamping and declamping of materials with the help of sending air pressure. And like we have, as we are going to use air pressure in industries, let us see composition of air. So we have in gas, like generally in atmosphere composition, 78 78 to 79 percentage is nitrogen, and we have nearly 21 percentage of oxygen, and argon is nearly 1%. Carbon dioxide we have 0.4 percentage, and remaining all are xenon, neon, methane, ethane, krypton, all other gases. So, and coming to air pressure, minimum pressure or atmospheric pressure we can call as 8 bar. Maximum pressure, which is used in general in industries, is 10 bar, and optimum pressure, where most of the applications run, is 5 to 6 bar. And we have water vapor. So there are many factors that influence the air pressure. In that, major thing is moisture. So whatever the relative humidity present in the atmosphere, what happens, that gets condensed inside the storage tanks or transfer pipes, all this. So to make this thing, we will be using we will be using air dryers, moisture removers, all those. Okay, and we have dust and dirt particles. In these dirt and dust particles, they are further classified or divided into two types: wet dust and dry dust. Dry dust is not a problem, but there might be chances of wet dust, problems with wet dust. Wet dust is nothing but whatever the oil we have been using, that gets mixed up with air, and that gets like vaporized and get mixed up with air, that will be creating a problem. So to remove these, we'll be using like aerosols, filters, all those. So I hope everyone has got an idea on pneumatics. In the next videos, we'll be going to see about different types of compressors, different types of components where we will be going to use. This video is just an introduction to pneumatics. So I hope you guys will be encouraging me. Thank you for watching the video. Please don't forget to like, share, and subscribe to Automation is Future. Thank you, guys.